now we're going to approximate limits using technology. The dividing out and rationalizing technique may not work when finding limits of non-algebraic functions. You often need to use more sophisticated analytic techniques to find limits of non-algebraic functions, as shown in examples 4 and 5. So we're going to approximate this limit. The limit as x approaches 0 of 1 plus x raised to the 1 over x. So what you're going to do is go ahead and use Desmos and the table feature. So what we're going to do is we're going to type in Desmos the limit as x approaches 0 of 1 plus x over 1 over x. You're just typing in this equation here. So I have a screenshot of what it should look like. So when you type it into Desmos, you make sure there's parentheses and that's in fraction form here. Then once you type that in, you press the gears button. When you press this button here, then you'll get this option where you can have a table and other things here, copying it. So click on the table, then you'll have a table. Then I already edited mine, so I just edit it to numbers that I want to see. So we're trying to get numbers that are getting approaching 0, right? The reason why we're choosing 0 is because it tells us here what happens to the limit as it approaches 0. So we're looking at numbers to the left of it and to the right, and we want to get as close as possible. So I went ahead and chose these numbers here. And notice, number 1, that because 0 here is halfway between the negative 0.001 and the positive 0.001, we can use the average to estimate the limit. So really all you're looking at is you don't need all of it. We can just look at the numbers that are right close to it. So you don't really necessarily need these numbers, but it is kind of nice to see what's happening to the function. And then if you're doing it in Desmos, you can also see the graph. Another cool thing, if you haven't noticed in Desmos 2, is that if you put your your pointer on the graph and you go to 0, you'll notice that it'll come up as a hole and it'll say 0 undefined. So very, very cool. So now what you're going to do is we're going to find the average to find out what is the limit as x approaches 0. We're going to approximate it. So we're looking at these two numbers, 2.71, I'm going to say 2.7196 plus 2.7169, and then dividing that by 2. And so what you'll find is that answer is approximately 2.71825. So sometimes we have to use this method in order to find the limit. So go ahead and try this example here. Approximate the limit as x approaches 0 of e to the x minus 1 over x. So go ahead and type it into Desmos, see if you can get the information and what you will find as the answer. So here's my table. I don't have the pictures that I took from Desmos. So I just wrote it down. And so I noticed to the left of the 0, negative 0.001, and to the right of 0.001, I have 0.995 and then 1.005, and I divide that by 2. And I find that it equals, or it's approximately 1, and then I'm sure if you looked at the graph, you would see that it does hit at 1 as well. Now let's try another example. Approximate a limit graphically. So again, we're going to type this into Desmos. So sine of x over x, you type it in. We're going to go ahead and choose some values to the left of it and to the right of it. So again, numbers that are fairly close, just so you can kind of see what's happening. I picked negative 0.001. 0, if we try to plug in 0, we know that is undefined. And then we try 0.001. So then if you plug this in, or I'm sorry, if you plugged it into Desmos, yes, then you would get 0.9999983, something like that. And the same thing on the other side. 83. So then you would add those two together, divided by 2, but I hope you see that they're the same exact number. So therefore you know that that approaches 1. But of course you could do the algebra involved in order to figure that out. And you would get 1. So try this example out using Desmos again. Approximate the limit as x approaches 0 of 1 minus cosine of x over x. So trying this out, in this case I use negative 0.1 and positive 0.1. Sometimes if you go a little too close to it, you'll get 0 or something like that. So maybe just go a little bit further out to the left and to the right, and then see what that might help you out a little bit more. So in this case, I chose negative 0.1 and positive 0.1, and I got 0.0499583. On the left, the negative. On the right, it was positive. So if you add those together, you will find that it is 0.